Hello dear friends, welcome to BYJU'S Exam Prep and I welcome all for this particular session of GATE 2024 Fundamentals. And in this GATE 2024 Fundamentals, we are learning basic concepts of discrete mathematics. Hi Vengideshan, good evening. Sayal Malik, hi sir. And SK Trench 04, hi sir. So in discrete mathematics, the last topic which I am going to discuss is the basic number theory. Of course, number theory is one of the very important topic, especially when you study this network security. Okay, the basis of this entire cryptography, which is basis for network security, is based on the number theory. Of course, in discrete mathematics, indirectly we use this number theory many times. So I just give you the formal basic ideas or basic results which we need to know in number theory in this particular session. Okay, sir. And this is about me, myself, Sridhar Dhulipala. Thank you, sir. Myself, Sridhar Dhulipala. Okay, I'm having 20 plus years of teaching experience and I'm associated with BYJU'S, as you know, from past 2 years. Under BYJU'S Exam Prep app, there is a particular category known as video lessons, where you can find the video lessons which were created. So with BYJU'S, you have double advantage. The recorded GATE content, the GATE content is recorded. It's not just recorded, sir. For this recording, we almost taken 1.5 years, where all the subjects of GATE are recorded in a proper manner, proper scientific and systematic manner. You can find these video lectures under BYJU'S Exam Prep app under the category video lessons. Okay, hi sir. And I recorded engineering mathematics for all the branches for our computer science students, discrete algorithms, programming and data structures. C and data structures were recorded separately. And you can join my Telegram group CS_Sridhar for regular updates about my classes. Okay, and you can also join my Facebook handle as well as Instagram. Okay, I'm not very regular with social media, but nowadays, of course, compared to last or past experience, comparatively I'm using my social media a bit. So let us start with the topic of today, basics of number theory. See, divisors, the concept of divisors. Suppose a, b and c are integers satisfying condition a is equal to b into c. A is equal to b into c. See, whenever it happens, we say that b will divide, because a is equal to b into c means you can write a by b is equal to c, or you can write a by c is equal to b. So it means what, sir? B and c divides a. See, here we need to understand the point carefully, sir. Divides means we need to get the remainder 0. That is the point to be noted here. See, here when you say, generally we may say numbers, then we are generally talking about natural numbers. Am I clear? Sometimes you may say integers, but sometimes when you say numbers, that means we are talking about natural numbers. Generally, if you are having 3 integers a, b, c, and if you are having the relation like a is equal to b, c, that means a by b is equal to c, means b divides a. Or a by c is equal to b, that means c divides a. So we write like, we use this pipe symbol to show that, or to say that b divides a. We read it like this: b divides a. And we write c divides a. C divides a. And obviously, when b divides a, then what happens? A will be multiple of b as well as c. A will be multiple. A will be multiple of bc, because bc's are a. Like that we can understand. So a becomes multiple of b. So b times c is equal to a, or c times b is equal to a. So a becomes multiple of both b and c, my dear friends. So that is the basic point to be noted. my dear friends. So you please tell me which of the following is true. See, when you say A pipe B, the meaning is A divides B, sir. The meaning is A divides B. That is, B by A should be constant. That is the meaning. That is, when you divide B by A, you should get answer constant. That is the meaning, my dear friends. Or if you say B pipe A, it means B divides A. So when you say 66 pipe 6, that is 66 divides 6. Is it correct? 66 divides 6. Is it correct? The meaning is you are considering 6 by 66. You are considering 6 by 66. Of course, okay, here you may get some fractional value, but we are not interested in the remainders, fractional quotients, my dear friends. We are interested in integer values here. So it is not correct. Very good, Subrajit Paul. And Nirmal's Samyal, very good. Sayal Malik also very good. Sham 1 and 4 are false, very good. 6 divides 66, it is correct, because 6 divides 66 is correct, because 66 by 6 is nothing but 11. 24 divides 24, obviously correct. 0 divides 24. See, 0 divides 24 or 24 divides 0, which one is correct? See, 0 dividing 24 means 24 by 0, which is false. So 24 divides 0 is correct. That is, 0 by 24 is possible. You get answer 0. So 2, 3, 5 are correct. Very good. Most of you given answers perfectly correct. Nice. The next question. How many positive multiples of 8 are less than 100? How many positive multiples of 8 are less than 100? Next concept, we are talking about multiples. Of course, they are all related to the divides and multiple of concept. See, if A divides B, B is multiple of A. Simple concept is, if A divides B, note this. When A divides B, obviously B is multiple of A. So how many positive multiples of 8 are less than 100? You have to find the multiples of 8 which are less than 100. So one way is you can directly list them. Positive integers. Now positive means 0, you can't take it. 8 multiple 8, you all know 8 table. 8 ones are 8, 8 twos are 16. Like that you can do it. That is 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, then 88 means 96. That's it. These are the positive multiples of 8. Wow, we done it. Right? But the problem here is, suppose here I given 100, you listed all the elements and you can tell me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can tell me the answer 12. What about if I give you how many positive multiples of 8 are less than 10 lakhs or 1 million? Can you list and write down? Can you list and write down? Can you list and write down, my dear friends? Okay. So we don't want to list, my dear friends. So whenever you need to find number of positive integers less than or equal to any number, just take that particular number and divide by 8 and take floor of it. You want to list or what? Nirmala, you want to list or what? Okay. Don't list. Without listing, see, that is what number theory will do, sir. See, the main aim of number theory is, without listing, you want to tell that answer. Am I clear? So here also, without listing, you can do it, sir. 100 by 8, you do it. 8 ones, 20, 8 to 16 point something. Take floor of it. The floor is 12. So directly I can tell the answer without listing all of them. Anyone done it? I don't know the answer. Someone is giving 124999 or 125000. Less than this means, okay, less than this means what, sir? Does it matter actually? Less than or equal to or less than? Less than this means what, sir? Less than this means 9999999. Does it make any difference? Please check. What is this and what is this? Please tell me what is this answer and what is this answer. Because less than 8, if I say up to 7, you have to take na? 1 less than. Yeah, Sayal. So what is the correct answer? Please tell me. Less than you are saying, no, less than means you take 1 less than. Don't take this. Here also less than 100 means you take 99 by 8. Of course, luckily 99 by 8 is also same answer. So less than you want na, take 1 less than that. So what is it? 8 ones, 8 twos, same in this case also same only. It does not matter. But sometimes it may matter. So the answer is not this one we should take. This is the correct one. So let us not take, okay, let me clear everything and write down. So because it is 99999 upon 8. So it is 124999. Okay. So that last fellow, that is 10 lakhs actually divisible by 8. Because of that we are having the problem. Suppose if 10 lakhs was not divisible by 8, both answers would have been same. But like unfortunately 10 lakhs is divisible by 8. Therefore that problem arises. Because you are talking about less than positive fellows. So 1 less than that. Why? What happened to Venkateshan? Why to 124912? Babu? Chinna? What happened now? What happened? So same thing, I just given it as a formula. The set of d multiples, that is multiples of 8 like not d multiples of multiples less than n you want, less than or equal to, actually he given less than or equal to. Actually here he given the formula for less than or equal to, because less than or equal to n you said, na? Less than or equal to, then you have to use n. Less than means n minus 1 you have to use. Suppose if it is less than n, you have to use n minus 1 by the d. If it is less than or equal to, you have to divide n by d, my dear friends. Just take care of that. Now the device, there are some very interesting results. These are the things which we generally ignore, my dear friends. Suppose a divides b and a divides c, a can divide their sum. If a divides b and a divides c, a can divide their sum. But if a can divide b, then a can divide any multiple of b. See, my dear friends, if a can divide b, you cannot say a can divide b plus c. See, if a divide b, you cannot say a divides b plus c. This is wrong. If you want to say a divides b plus c, for that what is requirement? A should divide b as well as a should divide c. Then only a will divide b plus c. Remember. Hi, good evening, Babu. Someone with my name only. Sridhar, calling Sridhar. Sridhar saying good evening to Sridhar, and Sridhar saying back good evening. Right. Now, a divides b, then a divides b into c. That you can directly say. And this is a transitive property, sir. This is a transitive property. If a divides b and b divides c, one of the very beautiful property in discrete mathematics also. Transitive property. A divides b, b divides c, then a divides c. All these are very, very useful results, my dear friends. And you all know about prime numbers. Prime numbers are integers greater than or equal to 2, which are divisible by 1 and the number itself. A number or an integer greater than or equal to 2, which divisible by 1 and the number itself is called prime number. Otherwise, it is called composite number. And remember, one is neither prime nor composite. One is neither prime nor composite number. See, there is one very, very, very important theorem. We actually call it as prime factorization result. Fundamental theorem of arithmetic. What is this fundamental theorem of arithmetic? Any number greater than or equal to 2 can be uniquely expressed as product of prime factors, and that we call it as prime factorization. every number greater than or equal to 2 can be prime factorized. Every number greater than or equal to 2 can be prime factorized. Are you able to follow, Babu? All of you able to follow? So for example, you take a number, say 18. 18 can be written as 2 into 3 into 3. And that is the unique way of expressing 18 as product of prime factors. Of course, you may say like you may say like 18 is equal to 2 into 9, sir. 1 into 18, sir. Babu, I am saying product of prime factors. I am saying what? Product of prime factors, and we call it as prime factorization. And for a number, there is a unique prime factorization. For a number, there is a unique prime factorization. That is not given by me. It's already there. We call it as first fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Okay, it is proved. Of course, we write it like 2 into 3 square. Okay, in powers we express this. I think you all know how to do prime factorization. You all know how to do prime factorization. How to do prime factorization? Take the number. Start with the least prime number. What is the least prime number? What is the least prime number? 2. 2 is the only even prime number. 2 is the only even prime number. You start with it. 2 divides. 2 nines. Fine. But next 2 does not divide. Very good, Nirmala. Sayal, you people are rocking. Vengideshan, not responding. I'm feeling bad. Sham, you are also not responding. Then 2 does not divide 9. So take next prime factor. After 2, next number is 3 is the next prime factor. 3 threes. Got it? So this is how we get it. You can try some more, Babu. Like 46. What is the prime factorization? For 46, what is the prime factorization? See, those who want to start their preparation for GATE, I suggest you to watch these videos which I done. This almost I think around 10 sessions I taken. So please do watch, because they'll give you a good idea of the logical way to think, the logical way to start this particular GATE preparation, especially for CSE. We'll discuss. Subject ball I'll discuss. Wait for some time. Okay, we'll discuss. 223. 223. See, now for 23, is there any other number? For 23, is there any other factor? See, for 23, you have to check not 2 divides, no, 3 divides. See, for any number, for 23, you want to check the factors. You don't have to try up to 23. Up to 23, it may look order n time, but if you consider the number of digits, okay, the complexity may go up to 10 power k, my dear friends. Okay, if it is a k digit number, 10 power k will be the complexity. It is very, very wild number. So what you do is you take root 23. You all know how to find. Okay, very good, sir. How to identify it is a prime? You have to tell. See, you can't do it not 2, you check 3, you check 5, you check like that. You can't check up to 23, na? So take root 23. What is root 23? Approximately. Approximately 5 less than, that is, what is the prime number less than root? See, root 23 is how much, sir? Approximately 5. Approximately 5. Okay. So you try prime numbers less than 5. What are the primes less than 5? It is actually less than 5 only. Prime numbers less than 5. What are the prime numbers less than 5? 2 and 3. Just check whether 2 divides 23. Not 4, sir. Primes. Babu. It is the story of primes. It is the prime time. So here carefully. 2, 3. Check 2 divides 23. No. 3 divides 23. No. There is no other number which divides 23. There is no other number which divides 23. You can stop there. Suprajit Pal, I reduce the complexity to root n. I reduce the complexity to root n. Am I clear? Yes or no? Now primality testing, that is what I told you. If n is a composite, then its smallest prime factor will be root n. Then its smallest prime factor will be root n. So for 23, you want to check whether it is prime factor, okay, composite number. Fine. Suppose you take any say composite number. Root 24 is what? Root 24 is what? Less than 5. So smallest prime factor for 24 is smallest prime factor for 25 is, or root for 24 is 3. So 24, if you observe, you can express only either in terms of 2 or 3. There is no other prime factor. So directly work with, yeah, you can do that, sir. That you can do 2 12s, 2 6ers, 2 3. See, it can have maximum, smallest prime factor it can have is 3. Smallest prime factor it can have is 3. See, of course, I think not smallest, sir. It is maximum prime factor. Not smallest actually. The maximal prime factor. You can say small, yeah, sorry. Maximal prime factor. See, obviously smallest will be, yeah, that's what, Sayal Malik, I changed it. See, Euler pi functions will tell you, Euler pi function can tell you number of positive integers less than n and relatively prime to n. It will not tell you divisors. It will not tell you divisors. Sham, that will not tell you divisors. It will tell you number of positive integers less than n and relatively prime to n. It will tell you. It will not tell you prime factors. That is wrong understanding or wrong statement. Now is that okay? Maximal prime factor. See, maximal means maximum. That is root n. It cannot go beyond that. That is what we need to understand. Now let us see prime factors for 214. Let us take few problems. Prime factors, let us find out. What are the prime factors for 2014? Prime factors for 2014. 8 means 8 is not a prime number, na? 8 is not a prime number, na? Take next previous prime number. What is previous prime number for 64? For 64, root 64 is what? 8. Prime number less than this is 7. Maximum, it does not mean 7 is a prime factor. Maximum, it can have 7 as a prime factor. Sayal Malik, we are just saying maximum, it can have that as a prime factor. It does not mean it is the prime factor. It can have maximum, maximum means less than or equal to. Maximum means less than or equal to. So 7 can be the maximum prime factor. Now you see people are doing, Venkateshan stopped with 2 and 1007. So he started with 2. So what happened? 2 will give you 1007. And Venkateshan felt that 1007 is prime number. Yeah. Now look here, for root 1007, what is the answer? Yeah, very good. Tell me root 1007, what is the answer? Root 1007, what is the answer? Babu, please answer the question. I know you got the answer. Wonderful. Congratulations. Root 1007, approximately 100 point something. So 100 point something is not that. So it should be less than 100. Or less than 101, let us say. Is it 100? 100, Babu? Who is that? Venkateshan Babu. Where are you? 31. 31 or 30? Please tell me exactly how much you got. 30 point something. Don't write 31 because that point something will not be considered now. So you have to take something less than that. 30 point something. So you consider the prime number less than this. What is the maximum prime? What? It's a 31 point something. Whatever. I don't know the number, sir. Whatever. So 31 point something. So you have to consider all the prime numbers up to 31. You have to consider all the prime numbers up to 31. 2, 3, 5, 7, 11, 13, 17, 19. Actually 2 does not divide, 3 does not divide, 5 does not divide, 7 does not divide, 11 does not divide, 13 does not divide, 17 does not divide, but 19 divides. 1953s. Oh, this statement I think we should reconsider because 53 is also coming now. 53 is also coming. Sir, for primality testing only we use it, sir. Not as a result. Don't use it as a result. For primality testing that is used. So don't take it in a more serious sense. Okay. Don't take it in a serious sense. Just to know up to what you have to check. Up to what you have to check. For that you consider this. Okay. Up to what. So up to this we have to check. Up to this number we have to check. That's it. Yeah. So please take it for primality testing only. Only for primality testing. Up to that number you have to check. Up to that number you have to check it. Sorry for that. Yeah. Sorry for that. Please excuse me for that. Yeah. So 19 you check and this is the answer. So 2014 is 2 into 19 into 53. Now you have a doubt whether 53 is a prime or not. You can check whether 53 is a prime or not. For that you can consider root 53. You consider root 53. What is root 53, sir? Less than 8. So you can try 2, 3, 5 and 7. None of them will divide. So it is a prime number. None of them will divide. Therefore it is prime number. Hope you understand. Yes. Shyam, what is the problem? Any twist? You are giving one more question. Acha. That is cute. That is so wonderful. Beautiful. Try this. Shyam, good problem. So Shyam taken this year because there was a GATE question based on this in 2014. So this year you can expect this question. Very good question. Very good. Very good, Shyam. Try prime factors for 2023. Nice. Next comes greatest common divisor and relatively prime. And you all know what is greatest common divisor? A number which can divide both these two numbers, that is both the numbers, is what is called as GCD, greatest common divisor. See, the idea behind taking root n is you can't get any number. Okay, you don't have to go beyond that and verify. If you can't find any root of that less than root n, you can't get anything greater than that also. That is the point. If no number less than root n can divide it, there cannot be any prime number greater than that. There cannot be any prime number greater than that which can divide that. Is that clear? Is that clear, sir? Okay, someone, he removed the statement. Now, one more thing. GCD. GCD is the greatest common divisor. Some people also call it as HCF, highest common factor. Greatest common divisor. The number which can divide both the numbers with remainder 0 and the greatest of such numbers. There can be many numbers which can divide both the numbers. For example, if you take 32 and 64, 2 divides both the numbers, 4 divides both the numbers, 8 also divides, 16 also divides. 32 also divide both the numbers with remainder 0. Out of this, which one is the greatest number which can divide both the numbers? 32, that is GCD. But there are few numbers for which the GCD turns out to be 1. The GCD turns out to be 1, and you call them as relatively prime. We call them as what? Relatively prime. Some people also call them as co-prime, sir. Co-prime also some people call it. See, if greatest common divisor for two numbers is 1, we call them as relatively prime, my dear friends. And suppose you have a prime number, this fellow will be relatively prime to all the numbers less than that. This fellow will be relatively prime to all the numbers less than that. That is, GCD of all these fellows will be 1. So that is the importance of prime number. For prime number, all the numbers less than that are relatively prime. All the numbers less than that, including 1, also relatively prime. Now finding GCD, of course you all know one technique, I know. Suppose you want to find GCD, the technique which you follow is 33 and 77. You divide the larger number by smaller number. Then you write 33 what? 33 2s 66 1 1. Then you take 11, the remainder, and you divide 33 by 11. 11 3s 33. You get the answer 0. Wonderful, wonderful. But is there any alternate method? Is there any alternate method for this? You do this. You want GCD of 33 and 77. So write down 33's prime factorization and 77's prime factorization. Write down prime factorization of 33 and prime factorization of 77. What is prime factorization of 33, sir? It is 3 into 11. Prime factorization of 77, 7 into 11. You got prime factorization? Got it? Now, if you want GCD, collect the common prime factors. Collect common prime factors. What is common? 11 is common, select it. 3 is not common, ignore. 7 is not common, ignore. So GCD is 11. This is prime factorization method. That is, you can write the prime factorizations for the both the fellows. Collect the common prime factors. That will give you the answer. Of course, common in the sense with power also, including power also. Suppose 11 square here, 11 square is, suppose for some numbers, 11 square is here, 11 square is here, we have to consider 11 square. For example, one fellow has 11 square, one fellow has 11 cube. One fellow has 11 square and one fellow has 11 cube. The common will be 11 square. The common factor we have to take it. Common factor. Okay? Common factor we have to take it. So you can try that. So people are given answer for this 11 they are saying, for this 12 they are saying, and for this 98 and 420. You can use division method or you can use GCD, I mean prime factorization method, my dear friends. Is it 14 for the next one? Is it 14 for the next one? People are given answer 14 for this. Okay, very good, super. Now least common multiple. You have to find the number which is multiple of both the numbers, but it is the least of such. Least common multiple. Even for multiple also we have two methods. One is you take both the numbers and start dividing with smallest numbers or smallest prime factors. 2 5s, 2 50s. Then 5 will go 5 1s, 5 10s. Then that's it. That's it. You can take prime or any common factors also will do, sir. So what is it? 2 into 5 into 10. Least common multiple, which is 100 only. Oh, very simple problem. Very good. Nice. You people are doing nicely. Or there is one more method. Method 2. You do the prime factorization for 10, which is 2 into 5. Prime factorization for 100, which is 2 into 5 or 2 square into 5 square. 2 square into 5 square. If you want LCM, you have to take the factor which is largest. For example, 2 is a prime factor available in both. One fellow is having 2 power 1, one fellow is having 2 square. You select the 2 square fellow. Not minimal, the largest prime factor you have to take. Whereas for GCD, the minimal. See, for GCD, when this is common, the smallest fellow you take it. When this is common, the smallest fellow, that is 5 power 1 and 5 square. Which one is smallest? 5 power 1 is smallest, that you select it. Whereas for LCM, take the largest, that is 2 square and 5 square. And in LCM, when you are doing LCM, suppose if there is a factor 3 there and there is a factor 7 here, you have to select them also. You have to select. It's kind of union. It's a kind of union of the sets, my dear friends. It's a kind of union. whereas GCD is kind of intersection. So the answer would be 100. Answer would be 100. Anyhow, people answered these questions very beautifully. This is 7, 5. What was the LCM? 35. For 9 and 21, what was the answer? 63. Yeah? Very good. Beautiful. And we have the relation between LCM and GCD. We have relation between LCM and GCD, my dear friends. Please remember, LCM of AB is given by AB by GCD of AB. Or if you multiply LCM with GCD, you get product of the numbers, my dear friends. If you multiply LCM with GCD, you get the product of the numbers, my dear friends. You can verify that. Okay. I given big numbers this time. Beautiful numbers. Please tell me what is LCM of AB. See, generally people feel when we say this particular method, people say, why we need this method, sir? We can happily do this method. Why you need this nonsense method? Now use that nonsense method or your regular method, dividing one by the other. Can you do that for finding GCD or LCM for this? Yes, yes. Please do. Please solve this. Oh, sorry. So find LCM and GCD. See, for GCD, 2 cube 2 square, you take 2 square. 3 cube 3 square, you take 3 square. 5 is not there, so ignore. 7 is there, 7 square, 7 power 1, 7 power 1, you take it. 11 power 1 and 11 square, you take 11 power 1. 13 square, 17 is not there in both, so ignore it. Common fellows, in that the small factor you take it. Whereas for LCM, 2 cube 2 square, the large factor you take it. 3 cube 3 square, large factor you take. 5 square is not there, so you take 5 square completely. Then 7 square, 11 power 1, 11 square you take it. 13 cube you take it, and finally 17 power 1. Cool. Sayal Malik, wonderful. Like that. So we should know the prime factorization. That is very, very useful. No problem. See, they just ask you the related questions, obviously, because when calculators are there, this can be answered. But I just want you to understand, because with this example, people ignore this method. But with this example, people don't ignore this method. The purpose is to understand this method. Don't ignore this method. To tell that I taken a big number, that's it. It was an example taken from Grimaldi. How many positive integers less than or equal to 100 are divisible by both 4 and 6? Good evening, sir. Poonam. Very, very good evening. How many positive integers less than or equal to 100 are divisible by both 4 and 6? See, normally, divisible by 4, you know it. If you want divisible by 4 less than or equal to 100, you can just do 100 by 4. Divisible by 6, you want to do it, you can just do 100 by 6. We done earlier. But if you want divisible by both 4 and 6, if you want divisible by both 4 and 6, it should be divisible by LCM of 4, 6. It should be divisible by LCM of 4, 6. You have to divide by LCM. See, some people divide by 24. Don't divide by 24. It should be LCM of 4 and 6. Okay, this one you can directly answer. 4 2s 8, 4 5s, 6 1 6, 6 6ers. Whereas here it is 100. What is LCM of 4 and 6, sir? LCM of 4 6 is 12. 12 8s or 12 9s. 12 8s or 9s? 9, na? 96. Sorry, 12 8s 96. Na? 12 8s, 8 is the answer. So it is useful for that particular purpose, my dear friends. Okay, these are the questions. Now from here, generally if you study discrete mathematics from me, obviously all this will be discussed. But the GCD LCMs generally I don't discuss. See, what all I discussed so far is assumed that you know it. From here, of course, it will be repeated some parts. Okay. Like, how many positive divisors of 300 are there? Positive divisors. All divisors I want to know. How many divisors are there for 300? So for this, we have a beautiful technique. Write down the prime factorization of 300. The prime factorization of 300 would be, what is prime factorization of 300? 2 square into 3 into 5 square. When you want to find number of positive divisors, you can happily do the following, sir. Each power you take and add 1 to it. Each power you take and add 1 to it. Each power you take and add 1 to it. So 2 plus 1 is 3. Multiply with 1 plus 1, 2. Multiply with 2 plus 1, that is 3, which is nothing but 18. There are 18 positive divisors. There are 18 positive divisors, my dear friends. So this is one of the interesting question. They ask how many positive divisors are there for 2014 also. Number of positive divisors of 2014 which we solved. Yeah. Positive means one also included, Sham. Positive means one also included. So, you can try this problem. There is one more question. They ask you sum of positive divisors. For sum of positive divisors, you can use the following formula. See, write down the prime factorization, which is 2 square into 3 power 1 into 5 square. You got it? Now, the sum of positive divisors is given by the sum of positive divisors is given by See, if it is 2 square, then it is 2 cube minus 1 by 2 minus 1. If it is 3 power 1, it is 3 square minus 1 by 3 minus 1. If it is 5 square, 5 cube minus 1 by 5 minus 1. Which will give you sum of all those positive divisors, my dear friends. Sum of all those positive divisors, my dear friends. Actually, the positive divisors you can get it by 2 power 0, 2 power 1, 2 square, 3 power 0, 3 power 1. If you expand this, you get all the positive divisors. You get sum of all the positive divisors. And for this, the formula, geometric series which I discussed in very first class, summation, sequences I discussed the formula. What is sum of this? A is 1, r power n plus 1 minus 1 by r minus 1. Using that you get this answer. Similarly for this 3 square minus 1 by 3 minus 1. For this 5 cube minus 1 by 5 minus 1. With that you are going to get that particular formula, my dear friends. With that you are going to get that particular formula. So these are some very basics which you should know, my dear friends. Yeah, simplified answer you can write down. Hope you understand. So it's a very simple basic results which hopefully most of you might be knowing, but I just want to discuss them, my dear friends. So I concluded this fundamentals 2024 for discrete mathematics. I think the next session will be for digital logic or digital electronics. Tomorrow this topic is completed here, sir. Tomorrow there is a generic session. The difference between MTech and MS, actually they call it as MS by research something. So there is a generic topic by me. I think at 9 p.m. there is a generic topic, difference between MTech and MS. So we'll meet for this particular topic tomorrow at 9 p.m. And my fundamentals for GATE 2024 for the subject discrete mathematics concludes here. And thank you for your patience, and you are all very supportive in these sessions. Please do share. Today it is finished, Poonam. Poonam, fundamentals, it is not discrete mathematics for GATE. Before starting discrete mathematics, what you should know, that I done here. Tomorrow there is a special session. That will be done, but in some order. Like next we are planning for digital electronics. From Monday onwards, digital electronics, what do you call this, special sessions or fundamentals will be discussed from Monday onwards. Okay, digital electronics. Okay, those fundamentals you can attend from Monday onwards. Tomorrow, as I told you, 9 p.m. there's a generic session. The topic is difference between MTech and MS by me. That see, there is a NEELIT series happening. Please do attend that NEELIT series. I think from Monday, those who are attending the NEELIT series, from Monday I am starting data structures for 3 days. I think 3rd, 5th and 7th. Data structures for NIELIT 2023 by me. See, YouTube, I'll be coming regularly for these YouTube sessions. Okay, so generally the main subjects which I'll be handling on YouTube would be like data, discrete mathematics, algorithms. Am I clear? This particular timing, I think maybe 9 p.m. only, sir. My classes are generally at 9 p.m. If any, please do join my Telegram group to know updates about it, sir. Please do join my Telegram group to get the updates. You'll get the updates about my regular classes here in my Telegram group. Okay, sir. So if you are attending, see, these are all basics which are useful for any level of discrete mathematics. These are basic fundamental classes. See you on Monday. Thank you.